talking about the perpendicular and angle bisectors from section 7.3. First, let's start with our table of contents. Firstly, we're going to briefly introduce the topic, and that's going to be our introduction. Then we're going to explain the topic with a few examples. We're going to do a brief explanation with 2 examples, and then we're going to talk about some applications on how we can use perpendicular and angle bisectors in real life. Then we're going to quickly conclude our topic. Firstly, the introduction. A perpendicular bisector is a line, segment, or a ray that passes through the midpoint of a segment and is perpendicular to it. So, as it says in its name, the angle here and the ray that passes through it has to be perpendicular to the line that it's passing through. And there's a theorem that's related to this. It says that if a point is on the perpendicular bisect of a segment, then it has the same distance. Another word for the same distance is equidistant. It has to be equidistant from the endpoints of that segment. Secondly, we're going to go on with our explanation and our examples. Okay, firstly, you have to identify the bisector. You're going to look for a square symbol. The square symbol means the 90-degree angle, and there will also be 2 lines typically at the bottom, but they don't always have to be. That line is going to show you where it's split into 2 equal parts. Then, after that, you're going to set up the equation. Because of the theorem that we just said, you know that the 2 sides that are split are equal. So, it'll be that the first expression is equal to the second one. Now, in other cases, you have to equalize your 2 congruent sides like we said, and then after that it becomes very simple. You solve it like a very basic and simple math equation. We'll show you how in a second. Now let's make some equations. We have these equations that we're going to solve. Okay, the first one, it says, what is the value of wy? You might be wondering, how am I supposed to find this? It's simpler than you think. You just have to equalize the wy, which is 2n plus 7, with your other angle that you have, your other side I mean, which is 5n minus 2. Now that's all you have to do, because those 2 sides, they're congruent, they equal. Now you just have to solve this normally, so plus 2, and then you're going to minus 2n minus 2n. You're going to be left with 3n is equal to 9. Now all you have to do is get rid of the n over here. So you're going to divide both sides by 3. Oh no, I mean you have to get rid of the 3. Then 9 divided by 3 will be equal to 3. So your n here is going to be 3. Now let's go back to our equation. All you have to do is replace the n here with 3. So that means 2 times 3 plus, 7. So 2 times 3 is equal to 6. So 6 plus 7 is equal to 13. So in that case, wy is going to be equal to 13. Now let's solve the second one. Let's erase our first example first of all. Okay. Your second example is a little easier. It says that this line over here, you have to find OL. Okay, that's OL. In general, it says J to L, so JNL is equal to 14. Now you have to find half of that. So OL will just be 14, which you're already given, divided by 2. OL will be equal to 7. That's all you have to do. It's a very simple topic. Now let's talk about some applications that we can use in the real world using this example, this topic I mean. It can be used in careers like archaeology, city planning, and engineering. Now, these geometry theorems, they're very useful and practical. They're essential to our jobs. They help engineers design stable structures for our planet, and they help archaeologists reconstruct artifacts that have been lost. They also help city planners optimize the space that they need. And they can do all this by ensuring that the things are perfectly centered, balanced, or divided, which you can do using the perpendicular bisector theorem. Now let's come to our conclusion. The perpendicular bisector theorem It proves that any point on the middle of a line